Alright, number 17. Write the inequalities that relate the measure of angle 1 to the measure of angles A and B. Okay, you know what? Let's look back at today's lesson. Okay, here is today's lesson. Okay, let's scroll down and take a look at, this theorem right about here in example 5. The measure of an exterior angle of a triangle is greater than the measure of either of the non-adjacent interior angles. This is called the exterior angle inequality theorem. Again, this means that angle 1, which is the exterior angle, has got to be bigger than either angle A or angle B. So this is one statement right here that would be true. The measure of angle 1 should be greater than the measure of angle A. But that's just one of the angles. It should also be bigger than the other one. So right here on example 5, the measure of angle 1 should be greater than the measure of angle B. Okay, those are the two inequalities that I could write about the exterior angle. So, as you can see, this is right from the lesson. And number 17 is not pretty much, it is the exact same thing. So, hopefully you understand number 17. Let's see, what's the other one that you asked for? Okay, 19 and 22. Okay, number 19. Describe the possible values of x. Okay, this one is a little bit different. Okay, well, let's talk about the possible values of the side that I'm putting in burgundy. In fact, can we call this C for a minute? So remember back at the lesson when we talked about this picture, okay, when we did example 4, if we were given two lengths like the 14 and the 10, and if I asked you the possible lengths of C, do you remember what the lower limit and the upper limit were? Well, hopefully you'll remember that the lower limit in this case was 4, and basically you could get it by subtracting 14 minus 10. You know, the idea was the shortest that this could be was what we would get if I brought this down. But if I brought this down, then right here I've got the 10, here the whole thing is 14. That leaves a difference of 4 for the length of C. Okay, 10 plus 4 would make 14. So that gave us the lower limit of 4. How did I get the upper limit? Well, I took this and I stretched it wide open like this. Okay, so let me put this on this side. So now C would now have to stretch all the way from one side to the other. Okay, so now C would be what length if I stretched it all the way out? Well, 14 plus 10, so that would be 14. That was the upper limit. So C had to be between 4 and 14. In other words, 4 is less than C, which is less than 14. So again, hopefully you followed all of that in moving around of the shapes. But the bottom line is, if you have two sides of a triangle given, if you subtract them, you'll get the lower limit of the third side. If you add them, you'll get the upper limit of the third side. Okay, so the third side has to be between these. It cannot be 4, it cannot be 14, but it would be between those. Now, looking back at the homework here, the two sides we're given are 8 and 12. So if I want to get the lower limit, once again, I would subtract these. So what's 12 minus 8? Yeah, that's 4. So, okay, the lower limit is going to be 4. So 4 is less than C, which is less than. For the upper limit, I would add these. Okay, because this is like the hinge right here. So imagine opening and closing this. Alright, if I closed it, it would make a difference of 4. If I opened it wide open, you know, if this 12 was stretched out like this instead, I'd have 8 plus 12, so that's 20. So 20 is the upper limit, I added. 4 is the lower limit, I subtracted these two. Okay, don't want you to be too distracted by these extra things. So the third side has to be between 4 and 20. But look, we have an actual expression for the third side. So instead of C, let's put 2x plus 2. Alright, so 4 has got to be less than 2x plus 2, which is less than 20. Alright, I just substituted the expression instead of C. So this expression has to be between 4 and 20. So it's just a matter of solving this equation. Well, look, if the 4 was not there, how would I solve this equation right now if the 4 wasn't there? Well, hopefully you said I would subtract 2 from both sides. Okay? Alright, well, what if the 4 was there? I don't know why I changed colors, but what if the 4 is there? Now imagine that the 20 is not there. What would I do now? Guess what? I would still subtract 2 from both sides. So no matter what, it looks like I'm about to subtract 2 from both sides. Okay, let me put this, put this back. So this is what I actually have at this point. I have 4 is less than 2x plus 2, which is less than 20. So if I want to get x by itself, no matter how I do it, I'm going to have to subtract 2. But I might as well do it on all three parts like this. Minus 2, minus 2, minus 2. So that's going to give me 2 is less than 2x, which is less than 18. Now, I need to get x by itself. It doesn't matter what's over here on the left and the right. Just focus on the 2x and tell me what I would have to do to get x by itself, to get rid of this 2. Hopefully you were just yelling at your computer or your cell phone saying, Mr. Burton, of course I would divide by 2 to get x by itself. I must divide by 2, because that way these will cancel out. And whatever I do to the middle, I need to do the same thing on the left and the right. Divide by 2. So that is going to give me 1 is less than x, which is less than 9. So guess what? These are the possible values of x. You can just leave it just like that. In words, x would be between 1 and 9. I'll write it that way too. X is between 1 and 9. Okay, same thing. That is how you do number 19. Now I believe you asked me to do number 22 as well. List 2 combinations of segments that will not produce triangles. Well, here's the key. I always like to start with the biggest side. Okay, so whatever I put next, I'm going to call that the biggest side. So say that's 20. So I'm going to pick 2 other lengths that are less than 20. if I want to have three lengths that will not produce triangle, the other two lengths have to fall short of 20. You know what? They could be exactly 20, and that would not make a triangle either. So, like, here's the idea. Imagine that I had a length here. You know what? I should use actual segments. Okay, say I have a length of 20, and now say if I have another length that's 10. Whoa, I missed. Let me try that again. Alright, say I have a length that's 10, and I have another length that is 5. Okay, so say that this is 10 and this is 5. Will this produce a triangle? No. This will not produce a triangle. Why? Because 10 and 5 only make 15. They will not meet. If I try to stretch this out in the right direction. Okay, there's my 10, here's my 5. They just won't reach. Alright, there's my 5. There's my 10. They only make 15. There's no way they're going to meet when the distance between them is 20. They just won't reach. So that would be a no. So that would be one answer to the question. List two combinations. So one answer to the question would be 20, 10, and 5. But there are infinite answers to this question. Okay, just to make a teachable moment. Imagine that instead of 5, this were another 10. Okay, say if I had 10 and 10 and 20. Would this make a triangle? Okay, well, we got to be careful. This will not make a triangle either, and here's why. This is 10, let go, and now this is also 10, so I can stretch that out. Okay, but here's the thing. These will reach, but just barely.
I have a big problem.
Alrighty then. These sides will just barely meet, but the only way that they will meet is if they are absolutely flat, like this, like this, like this. That's the only way these sides are going to meet. And when they're flat like that, that does not make a triangle. So it's not good enough if they add up to exactly the same as the bigger number. They have to be adding up to more than the biggest number. So this is another example of a no. So this is a good one. So I could put 20 and 10 and 10. That would be another no. Okay, so just for contrast, so so these would be some no's. If I wanted some yeses, which is not what the question asks, but just for teaching purposes, if I had 20 and 10 and, quick, imagine a number that would work, that would make a triangle. Say 11, 12, 13. I just needed something where these two numbers would add up to be more than 20. And if I pick 11, 10 plus 11 is 21. That's more than 20, so that would work. So that would be a yes. Okay, here's another example of a no. I'm going to change the first number. Say if the first number is, say if the biggest number is 10. Okay, think of some no's. Think of some no's. Say if the next number is 6. Okay, what would the third number have to be to not make a triangle? Would it work if it was 5? Yes, it would make a triangle because 6 plus 5 is 11. That's more than 10. Would it work if it was 4? No. 6 plus 4 is exactly 10. Not good enough. It has to be more than 10. So that would be a no. And of course, 10, 6, and 3, anything smaller would definitely be a no. On the other hand, some more yeses would be, like 10, 6, and 5. Or, or 10, 7, and 8. As long as these two numbers, the two smaller numbers, add up to more than the biggest number, it's going to be a yes. Alright, but the question only asked for no's. So there, I've given you 4. But look, people doing your homework, I don't want to see any of these answers on your homework paper. There are infinitely many answers you can come up with. So if I see any of these 4 on your homework, I'm not giving you credit. Come up with your own. That's fair. I think we'll all agree that that's more than fair. Okay, this video is getting to be too long. So, adieu. Adios. Buenas noches. Good night. Auf Wiedersehen.